And what we're going to do is extend off of the ideas from the previous section. So a good amount of the material in this section will follow directly from the last section. You will see a lot of recurring themes. It's just we will add a little bit of terminology, the amortization, and we're going to add a new formula. So I'll start off with the terminology. Amortization, pretty much a payment plan. That's it. You pay off some debt in a specific length of time by equal periodic payments. It's a payment plan that includes compound interest. That's amortization. So if someone says amortize, all it means is a payment plan that is compounded through compound interest. But if you see the word amortize or annuity, which we talked about annuity in the last section as an account you put money into, amortization is an account you're paying off. We treat it the same exact way though. They're just, we're going to treat them very similar. The only difference is one of them is going to have PV as a defined value and one's going to have FV as a defined value. And the interest is something we can compute to determine, well, when you borrow an amount of money, obviously you pay it back and you pay back the interest as well. Previously, well, in the last section, we were not focused on determining the interest as a standalone value. It was just kind of thrown in there. But now we're going to isolate what the interest is. We can actually compute it. And really what this is saying is the amount of the loan is one of the values, and then the other value is really how much you pay back over the periodic cycle that you're paying off your payment plan through. And so that difference intuitively, so this is an intuitive definition, what I just highlighted around. This difference will in essence show you the amount of interest that you either paid back if you borrowed money or that you got as a bonus if you invested money. So that's more of an intuitive definition that actually might also help you with the homework problem as well. But really what we're going to focus on is this formula down here. This is what we're going to be using for every problem. This breaks down those words into symbols that we can define. And once you figure them all out, you could just plug in directly and be good to go. Now you might notice under amount of loan, it says PV or FV. So when you're determining interest, you're going to be picking the value that is non-zero. So it says PV or FV, and all that means is, well, use whichever one is the non-zero one. Because last time in class, I mentioned that PV or FV always has to be zero. One of them always has to be zero, and the other one is, well, not zero. So the non-zero one will go into this formula. And then PMT times N, that plugs in directly as you would think. You find PMT, you find N, plug them in, and you're good to go. So from here, let's move on to example 1. Now, I went online and saw that Discover offers a 36-month personal loan at 6.99% compounded monthly to applicants with good credit ratings. So practically speaking, it's a much better, I guess, interest rate than other places, or if you have bad credit. So suppose you get approved for this personal loan and you can afford monthly payments of $250. So then the question is, using all that information, how much will Discover let you borrow? If you are approved for all of this and you can afford monthly payments of $250. Now this problem is going to start off the same way that problems in the last section started off. So this will be a nice warm-up to remember what we talked about, well, last week. So if anything, I with the percent is the interest rate, so I'll fill in the easy one. Does anyone happen to remember filling in the blanks for any of these?
N is the total number of payments. 36.
Yes, so N is going to be 36, and just 36. If you think from last time we said that N was a product. It was the amount of time times the number of times you're paying in a month or a year. So why are we not multiplying now?
36 more.
In other words, they're doing the product for us. They're doing the multiplication for us. They could have worded it as 3 years and you're paying monthly, but they just threw it, they multiplied the two things together already. So they're just giving us that product already. It's 36. So that's that. So what about any of the other values?
Payment of 250.
So remember, PMT is
Negative.
Yeah, PMT is always negative. So remember that from last time. PMT is always negative, and it's the amount of payments you make in a month or a year, whichever one it may be. So that is 250, because this says monthly payments of 250. That is the indication here. And even with that part underlined in blue, that actually helps us figure out two other values fairly quickly. Yeah, PY and CY are both 12. The amount of payments in a year, well, if we're doing everything monthly, this happens 12 times a year. So now we get down to PV and FV. Remember, PV and FV, these are closely related. One of them should always be 0, and the other one should, well, not be 0. So how much can you borrow from Discover? Someone who's not you, because you probably know it. Which one of these should be 0? What's that?
Future value.
Future value should be 0. And so remember the thought process. Thought process is if you're borrowing money, you're starting off with a debt, and in the future, how much do you want that debt to be? 0. You want to have no debt in the future. That's why I'm putting 0 for the future. It means you're going to be starting off with some amount of money that you borrowed. And in essence, because every other blank is filled in, you need to figure out PV. That's the unknown value here. It's PV. So far, this is starting off the same way that problems in the previous section started off. So I'll pull out the TI calculator. So remember, the TVM solver, apps, enter. Go ahead and plug in some of these values. Now, I had 1 or 2 questions about this. So PV, if you get rid of the value, so notice as it's blinking, there's no number there. If you try to get away from that, the calculator will not let you. It demands a number. It has to have a number. So I always put a placeholder 0 just to shut the calculator up. That's why I'll put this little notation of parentheses with a 0, just a 0 placeholder. So now you can move around and you can come back to it later. PMT is negative 250, FV is 0, and P over Y, C over Y are both 12. Remember what we did last time. And if you forgot, I'm going to detour right fast. If you forgot this whole process already, because it has been 5 days since we last met, the whole process is in the previous section, tells you step by step what to press, what everything means. So before you get too confused with it, you can use that as a reference. But what it does say, you move your cursor up to the unknown value, which is PV in this case, press alpha, well, it's green on this calculator, enter, and you should get 8,097.82. Wants us to round to 2 decimal places, so I'll round up from 81 to 82 for the cents. So that already answers part A. So far, it looks like, well, what's the difference between this section and the previous section? Because that was exactly what we did in the last section. It's the part B that is the new stuff. Just notice now there's a part B at the bottom. And part B wants to know the interest. So Discover's letting you borrow a lot of money here, $8,000. But Discover, as I mentioned in one of the first class sessions, Discover is not your friend. They do not care to just let you borrow money and then you pay it back on your leisure. They want a profit out of it. They're a business. They're trying to figure out how much of a fee that they can charge you for them to profit off of loaning you this amount. So the way we determine this, so I'm going to use the formula that's exactly on top of the screen here. The interest, and if you see the formula I circled on the very top, starts off with absolute value bars. Basically, those absolute value bars mean if you get a negative number, make it positive. If it's positive, do nothing. So it's an absolute value bar, so I have that. And then it starts off saying PV or FV. Now we choose the one that is non-zero. Hopefully you look at those numbers listed in part A and see that, hey, it's PV that is non-zero. FV is 0. So really it's PV that we use in this problem. And then besides for that, PMT times N follow no matter what. That's always gotta be consistent. So now, let's go ahead and actually plug in numbers now. PV is $8,097.82. PMT is -250. And capital N is 36. Now really technically there is an absolute value symbol in the calculator, but I think it's a little bit gratuitous to use, especially since all we have to do is interpret the results. So I'll just ignore the absolute value bar. 8097.82 plus -250 times 36. The absolute value bars would tell us if your answer is negative in the calculator, just write down the positive version. So we'll do exactly that. So this is $902.18. And so this is the interest that you would be paying. So provided you borrowed a little over $8,000 from Discover with all of these other values and characteristics at play, you will be paying back the $8,097.82 that you owe them. And on top of that, you would be paying an interest of $902.18. So it's a decent amount of money. For some people, that may seem like a good deal. For others, that may not. Depends on your financial situation. But that is pretty much the art of finance. That's how they make their money. That's how much interest you would pay. So that's the new characteristic that shows up in this section. Does anyone have any questions about this so far? If not, let's move on to part C. So part C, this isn't really a problem you're going to see in your homework. What part C is really my way of bringing a little bit of a real world connection into this topic, because part C is what happened to me. So when I was a grad student, I borrowed $3,000 because it's a little rough when you're a grad student. So I took out a personal loan at 6.99%. I borrowed $3,000, and instead of paying it off in 36 months, I paid it off in 12 months. The reason why is because you will pay a lot less money when you pay it off a lot more quickly. because there's a lot less interest that gets accrued over time because there's not as much time for the interest to get accrued. Plus, the more you pay off, the less interest will be accrued from the balance amounts. So part C, if you just want to, you can write it out for completion, but really this is my way of urging you to pay off debts quickly rather than follow the minimum payment that is normally provided. So if I want to put this in some refined form, I want to borrow $3,000. I have no idea what my monthly payments would be. I'm going to be paying monthly. I hope I have $0 debt. 6.99% is the interest rate that I did. Let's say I paid off in 12 months. So how much did I pay per month on average? So by paying off over 12 months, so I paid off over 12 months, the value I paid off was $3,000. I'm going to write down the ones that actually help me find the interest later on. And the payments, the monthly payments that I made were negative $259, and we'll call that 57 cents. These were some of the values. So those are the payments I was making each month. And then let's compare that to if I were to have paid off over the course of 36 months. So 36 would be the new N, PV would be the exact same. And how much would I pay a month is the new question, because that's going to change. If I change N to 36, how much would I be paying each month? Or in other words, how much would Discover expect me to pay each month? $92.62. So Discover could come up to me and say, hey, all you have to do for this personal loan is pay about $93 a month. And it seems nice on the surface. But by choosing to pay more incrementally over the course of 12 months instead of 36 months, I saved money. And now we can actually figure out how much money did I save. So the interest over 12 months, I'll call it I with a little 12 next to it. So the interest over 12 months, absolute value of PV, actually I won't even write PV now. I'll just write in what PV was, which is 3,000, plus the PMT, which was $259.57, times the 12 months I paid it off in. And similarly, I could do the same thing for if I would have paid it off in 36 months. 3,000 plus negative 92.62 times 36. We can figure out both of these interest values separate. So let's see the top one. 3,000 really minus 259.57 times 12. So by paying it off in 12 months, so the big summary to all of this is by paying it off in 12 months, I only paid an interest of $114.84. Now, what about if I paid this off in 36 months? How much money would I have paid in that situation? 92.62 times 36. I would have paid 200 more. 234.32. So that's how much more money I would have paid if I would have paid in 36 months instead of 12 months. Or that's how much money I saved by paying off after 12 months instead of 36 months. So basically, I saved how much money? Just the difference between the two. $334.32 minus 114.84. Save $219 by doing it this way. Which answers the question of how much money you would save. Again, not really a problem you're going to see on your homework, but really my way of urging you all to not be fooled by, so if you have a credit card and you have some debt on the credit card, so Discover, just personal experience, I know Discover normally, depending on your credit, they'll let you pay a minimum amount of $35. Maybe different, but at least on mine, it's $35 each month. It sounds very great, only having to pay $35 off, but they want you to have more money in your account so they can charge you more interest. So there truly is a benefit to paying off more whenever you can, because that's less money you have to pay later. Does anyone have any questions before we move on to the next example? If not, let's go ahead and see example 2. Scroll down to example 2 now. So example 2, suppose a computer manufacturer offers a 60-month payment plan at 1.82% interest per month. If you purchase a computer from the manufacturer for $2,944, so pretty expensive computer to say the least, how much are your monthly payments? Round to 2 decimal places. Okay, so we can go ahead and start off. These problems, again, start off the same way they did in the previous section. So what are some of these values?
I equal 1.82.
We'll start off with the I one. And what were you going to say?
I was going to say PY and CY should be 12.
PY and CY should both be 12. I'll go ahead and fill in that one because there's something interesting about the interest rate here. So if anything, those should both be 12 for PY and CY because we're doing everything monthly. Monthly, month, blah, blah, blah. The interest rate here, this is the only reason why I picked this problem. You would look at it and think, all right, 1.82. It seems very persuasive.
Times 12, right?
It's going to be times 12. And you're probably thinking, why is it times 12?
Because it says per month.
It does say, yes, exactly. It does say per month. So this is the only problem that I saw. Maybe there's another one, but this is the only one I recall that will mislead you into thinking that 1.82% is your interest. But in actuality, because they say per month, so think about it from some, I don't know, loan company or the computer manufacturer's perspective. By saying 1.82% per month, you're looking at 1.82, which is a very good interest rate. But that's per month, which means they're dividing the true value by 12. What you're actually paying is 21.84% interest. So that is, frankly, a ripoff. In my opinion, that's a very high interest rate. That is a very high interest rate. But tactics like this are done all the time. People do stuff like this pretty frequently. You're looking at the 1.82 and they're looking at the per month, thinking, all right, we just got them to sign up for this crummy deal. And now we're going to be able to see how much interest this person is going to be paying back on top of paying back the $2,944. So aside for that little caveat, the rest of these values should work out fairly expectantly. So
N equals 60.
So n is 60. N is indeed 60. Because again, they did the product for us. Instead of saying, what is it, 5 years and paying monthly, they're just putting everything together. And
Your PMT equals negative 2,944.
in this situation,
That's the present value.
yes, so the present value is actually the 2,944. Because that's how much debt you're in at the moment. You buy the computer, and now you got to pay off this money. The PMT, well, if anything, if PV is a number, then FV has to be 0. Because one of those are directly related. If one is a number, the other one is 0. And guess what we're looking for? We're missing one, PMT. Which again, I use that parenthesis 0 as a notation to indicate we're going to put a placeholder there. And by figuring out all of these values, we can go ahead and plug directly into the TVM solver. So 61.82 times 12. Again, you can do products and stuff in line in the TVM solver, and it'll solve for you. 2944, placeholder 0, 0, and then some 12s. Remember, we bring our cursor up to PMT, alpha, enter, and what we get is negative 81.04. When we provide the final answer, my math lab wants this as a positive value. They want the magnitude, because the negative is simply a way for the calculator to understand the direction and transfer of money. So to us though, I don't tell you, you owe me negative $81. I just tell you the magnitude, and we understand the direction of money. Negative's just for the calculator. And then my math lab is its own kind of nitpicky, whatever you want to call it. So in any case, these would be the monthly payments. So expect to be, in this situation, expect to be paying $81 for the next 5 years of your life for a computer that's hopefully worth it. But part B is going to put all this together and think, well, the $81, that sounds very good on the surface, but how much money are you paying to the computer manufacturer? How much money are they getting in profit from you? How much money are you paying extra, in other words? And so I'm going to bring up the interest formula again. And if you recall, the interest formula starts off with absolute value. And we put either PV or FV, depending on which number is non-zero. Here it's clearly PV. That's the non-zero one. And that's plus PMT times capital N. And from here, we just plug in the numbers and solve accordingly. So PV was 2,944 plus negative 81.04 times capital N, which is 60. So we can quit out of this, clear the screen, 2944 minus 81.04 times 60. So the interest in total, we want the positive value because of the absolute value. It's $1,918.40. So let's think about what that means. You're paying roughly $3,000 for a computer, and on top of paying back that about $3,000, on top of that, you're paying an additional about $2,000. So that's a lot of money you're paying back. So this is when you break down the numbers, this is really a horrible deal. This is a horrible deal. That interest rate is so high. And it sounds great, the $81, but you have no idea. The number's so low, you have no idea, how much you're really getting ripped off. And this is, again, as I mentioned in the previous example, this is stuff that people get paid big money to sit around and think about how to manipulate you and how to get you to spend a little bit of money now to maximize their profit in the long run. That's why it's better for you to pay off things a lot more quickly if you can. Sometimes the situation's perfect for people who get paid monthly, so that's perfectly fine. But it's good to be aware of the situation you may be putting yourself in. Does anyone have any questions? That's another good example. I think in a previous class I mentioned I'm making a payment plan on a mattress I recently bought. I'm paying it off in 3 months. So if I paid it off in 12 months, I would have had to pay an extra $2,000. At least they were generous enough to tell me that in the beginning. They said, if you pay it off in 3 months, you pay off the mattress with no interest. You pay it off in 12 months, you're going to pay an extra $2,000. So they told me, well, don't make the dumb decision. Pay it off in 3 months. So moving on to example 3, there's this company that provides an annuity. So an annuity is a savings account. So you're putting money into it. It's not a debt. It's some account that you're going to be building up. It pays 6.9% interest compounded monthly. And let's say with this annuity, you're going to take $845 out of your monthly paycheck, put that straight into the annuity. How much is in the account after 11 years? So, besides for the obvious value of 6.9% interest, does anyone see any of these other, what you got?
It should be 11.
12 times 11.
You don't forget the times 12. Now they're misleading you. We were getting, spoiled there. It's 11 times 12 because now they don't tell us the total number of payments. So there's 11 years and this is being done monthly, which automatically tells us two other values. D over Y and C over Y. Those are both 12 because we are doing everything monthly. So, also, $845 is what's being deposited every month. Hopefully that spells it out. Yeah.
Is 845 for FB or is it for PB?
So, since this is being deposited monthly, it's going to be PMT. Whatever is your periodic payment will always be PMT.
Is FV 0 because you want to know how much it is in the end?
Yes, so the virtual person who just mentioned that, we start off, so this is going to be a little bit different from the previous problems. We start off with no money. This is not a debt. This is an account that we are saving up in. So this is on the assumption you open up the account, you have no money in it. And how much is going to be in it after 11 years? That is the question. How much is in the account after 11 years? Now that we have all of these values figured out, 11 times 12 is 132. 6.9 there, 0 there, negative 845 here, placeholder 0 there. So once we fill in all the values, we're looking for FV. So alpha, enter. So this is $166,281. And notice it does say round to the nearest dollar. They throw in that little, that little detail as well. So I'm going to leave it at the nearest dollar. So that's how much is going to be in the account. So just think about that. If you put this money into an annuity in 11 years, so a lot of you are probably, fairly young. 11 years, you'd be what? Maybe 30, close to 30. Imagine by the time you're 30, you have over $100,000 sitting in the bank waiting for you. This is provided you can dedicate $845 of your paycheck each month, which times are tight enough as it is. But just thinking about it pragmatically. So that's part A. It's a future value rounded to the nearest dollar. And then part B is going to be the same thing we talked about before. How much of this is going to be interest? So now, like we did before, we're going to be figuring out the interest. Remember, it starts off with an absolute value bar, and then we use either PV or FV, depending on which one is non-zero. It's going to switch. Now we're using FV, because now FV is the non-zero value. And then this is followed by, everything else. PMT times N. And now we can go ahead and start plugging in values. FV is 166,281. PMT is negative 845. And is, 11 times 12 is 132. So what does this come out to be? Let's find out. So 166,281 minus 845 times 132. So this is saying, so the final answer for the interest, rounded to the nearest dollar, is $54,741. Now what this is telling us is for investing with this company for 11 years with this annuity, they're giving you about $55,000 basically as a bonus for you investing with them, or letting them be able to handle your money in their account. So that's pretty nice. You had to do virtually nothing for that money. So that's pretty nice to have after 11 years. Does anyone have any questions about this before we move on? Okay. So, how's everyone feeling about this stuff so far? Well, let's make it a little bit more complicated. It's a math class. Unfortunately, that's always a factor to keep in one's mind. So, example 4 starts to introduce the idea of a down payment. Now, you might be wondering, what is a down payment? Down payment, put very simply, it's a lump sum that you pay. It's basically a chunk of a total amount you have to pay. You pay this lump sum. And the reason why you do this is because the amount of money in this down payment you pay does not accrue any interest. So you're paying this off because the amount that's there after the down payment is much smaller, and by definition will accrue less interest than, say, if you did not put a down payment. Plus some places make you put a down payment as well to make sure you're you mean serious business. And so one of the situations we see this in, example 4, some probably really close friends who want to pay off a house over the course of 30 years, they just put down $28,811 on a new house. So they're doing that because now that $28,811 will not accrue any interest. So it will make the interest that they pay later on smaller. And so let's say the interest rate is 7.2% compounded monthly. What was the selling price of the house? So I bet a lot of you are looking at this. Well, actually, I won't even spoil that part yet. Let's just put in some of these values as we think are intuitive. I'll do the easy one, 7.2. We want to take a crack at any of the other ones. Maybe a new voice. Someone who hasn't.
N would be 12 times 30.
And would in fact be 12 times 30. Because it does say 30 years, we're doing everything monthly, which already tells us 2 values for free. 12 and 12. Because we're doing everything monthly. What about, again, someone who hasn't answered yet?
PMT would be negative 727.
PMT is in fact negative 727. Okay, and before someone says the next one, I bet that I've seen this every semester for, good reason out of context. A lot of people want to say PMT is 28,811. Well, let's think about that route if we were to do that. I'll write this in blue, so don't write this part down. Then you would put 28,811 because that's the amount you start off with, and you would think, all right, and then once I'm done paying off the house, I'll owe nothing. Well, what would you solve for in that case? There's nothing to solve for. So that there's got to be some flaw in our logic. If anything, your thought process, if you did it that way, is partially right for FV. You want to end up owing nothing on the house after you pay it off over the course of 30 years. Problem is, PV is not 28,811. In fact, all right, I'll say this probably a few more times after this first time. Down payments are not involved in TVM calculations. Down payments are not involved in TVM calculations. The reason why, what's the point of making a down payment if it's going to accrue interest? The reason you make a down payment is so that it will not be involved in the interest, in the TVM interest process. So a down payment should not be put in any of these blanks because it does not accrue interest. This formula is just for interest. So you might think, well, what goes into PV? Well, that's a good question. That's what we want to know. That actually will answer the question. The 28,811 is not currently being used in this problem. Not yet. So we're trying to figure out PV here. This is also characterized by what was the selling price. So we're looking for an initial value. So if anything, let's figure out PV. So that's where down payments make things a little bit difficult because they can throw numbers around that may not be relevant at first. So let's go to apps, enter. 12 times 30, that's just 360. 7.2, placeholder for PV, negative 727 for PMT, FV is 0, and then a bunch of 12s. Plugging in everything like that, we get that PV. Comes out to be $107,102.63. And so you probably think to yourself, okay, well then that was the original selling price of the house. The answer is,
Do you add the down payment?
I was only able to hear the first part of that, but I think what you said was correct. For the virtual person who just asked, what you do is you take so to kind of interpret this, what that PV is telling you, that was the original price of the home after you made the down payment. Because the thought process here is, after you made the down payment, now everything left over will accrue interest. So we have to work backwards. So to figure out the original price, it's going to be the amount of money after the down payment. Now we have to add what the down payment was. We're working backwards. And by determining this, we will get the true original selling price of the home. It's 107, 102.63 plus, oops, that's times, plus 28,811 to get 135,913.63 cents. And this was the starting price of the home. So again, the thought process is, you finally agree on an offer. The realtor says, all right, they closed with all the fees and stuff included, you got to pay this amount of money. You pay the down payment of $28,811, and now the amount left over is the $107,102.63, which then that part will accrue the interest that you have to pay off over 30 years. So that's what we've done, but we went backwards to kind of unravel the situation. So that's part A of this problem. That's how down payments sort of throw a wrench into the, I guess, this sequence that we're getting familiarized with. Does anyone have any questions so far about part A? If not,
so down payments, you're always going to be finding PV first?
In the scope of this class, that may be true. It depends on the context, though. I mean, really, I'm trying to think of an example where it might not. I'll say sure for now, but that's just by coincidence. It's not really by anything else, at least that I can think of.
So you will never subtract the down payment, you will always add?
Well, it depends on what the problem's asking. So the next problem, just I suppose hang on to that question you asked for after the next problem.
Okay.
Yeah, because the next problem also deals with down payment, but in a different way. So hang on to that question. If you still have it, you can ask me after example 5. Example 4, let's go back to example 4, part B, and just figure out that interest, which that's still going to be the same. Down payment or not, interest is still solved the same exact way. The interest is the absolute value of whichever value was non-zero, that was, well, between PV and FV. So that's PV plus PMT times N. And now that's, so what a lot of people like to do, I've seen in previous semesters, they'll take the answer from the previous part and put that in for PV. This value we found right here is not PV. It's not PV. PV's over here next to PV. So make sure you use the correct value. It's the 107,102.63.
I have a quick question.
Yes, what you got?
Is my math lab going to be asking for PV or the original price?
it's going to ask whatever I normally have boxed in red for that corresponding part. So in part A, it's going to ask for the 135,000.
Okay, thank you.
So let's see, plus PMT, which is negative 727 times 360 it comes out to be. And let's see what the calculator tells us. $107,102.63 minus 727 times 360. Absolute value says ditch the negative sign, you get one. So that's $154,617.37. So let's think about what that means. So let's think about what that means. You agreed to pay off or buy a house for $135,000 blah blah dollars. On top of paying that amount back, you were paying an interest that is more than the price of the home in the first place. Seems a little sleazy, but 30 years accumulating so much, such a volume of money, this is kind of expected in these circumstances. I mean, that's a lot of money that, say, if you take out a mortgage, it's a lot of money they're loaning you, and as such, they have a lot of leverage to really have you pay back this amount of money. So interest like this is not uncommon by any means. And again, this is why, a house note of, having a house note of $727 a month, that's pretty generous on its own. Some people pay rent for that amount. If you doubled that and paid that each month, this number would go down drastically. But just things to keep in mind, just from an intuitive perspective. But irregardless of that, does anyone have any questions about example 4 before we move on? If not, let's scroll down to example 5, which is another down payment type problem. So there's a sailboat, costs $24,470. You pay 15% down, okay? Pay 15% down and amortize the rest, so payment plan, with equal monthly payments over an 8-year period, all right? So you're paying it off over 8 years. The interest rate is 6.9%, compounded monthly. So what's your monthly payment? So let's start filling out some of these values. Let's hear some new voices. Anyone want to give it a shot? You got one?
I would be.
If not, no.
15%.
So this is how they trick you. This is how they trick you. They threw 2 percentages in this problem.
Would you use 6.9?
Yeah, so that one, so they threw 2 percentages in this problem, partially to mislead you. And so I'm glad you mentioned that, so we can see that the interest rate is 6.9%.
Will the 15 just be like instead of adding how we did the last one, will it just be like whatever PV is or FP, I guess, will be like 15% of that?
You're on the right track. You are very close to what we have to do. So hang on to that. We'll come back to that. What you got?
Okay, so in the problem with the 2 percentages, how do we know which one to use?
How do you know which one to use? 6.9% compounded monthly. It's all kind of a phrase. It's not just disjointed, numbers and phrases. That's all. There's that accompaniment that associates that 6.9% as an interest rate, as opposed to 15% down, which tells you another context.
Is PY and CY 12?
So PY and CY are both 12 because we're doing everything monthly. And Additionally, let's see. So notice it says 8-year period, 8 years, but we have to multiply by 12 because we're doing everything monthly. They don't give us capital N for free. And so what we're looking for, so we're looking for PMT. What is your monthly payment? If anything, we're looking for PMT, which means PV and FV, we should be able to plug something in for them. Now, if anything, which one of those is 0?
PV.
F.
It would be
FV.
EV is 24,000 times 0.15, or the number.
Okay, hearing a lot of things. FV is 0, that's what I agree with. Because you're starting off with this debt for the sailboat, and you hope by the end of this 8-year period, you have no debt. So FV is 0. PV, though, I've seen this too, and this is what makes this problem a little complicated. Everyone wants to put 24,470 for PV. That is not correct. That is not PV. And you might think, well, why not? It's so tempting. It's right there. Isn't that the amount of the boat? I mean, it would be, but you made a down payment. Down payments should not be included in your TVM solver. You might think, well, how do we figure that out then? I'm going to put PV down here. So what we have to do, so if anything, it says 15% down. So we can figure out 15% of 24,000. I'm putting a little bit of space on purpose. 0.15. That's how we find 15% of the 24,000. Blah, blah, blah. But that's the part we don't put into the TVM process. So what part do we actually put in? It's 24,470 minus that 15% deduction, because you're subtracting off 15%. That's what it means to put 15% down. So this problem is tricky for that aspect alone.
So then whatever you get from that, that's your PV?
That's your PV. Now there's another way you can represent this. Always get maybe one person per class who can figure out another way to write this as just one multiplication. Does anyone happen to see it? Just blank times blank.
8 times 12? No?
So
Is it 0 times 0.5?
I'm going to write down what it is and then explain why. You might be thinking, where in the world did I get 0.85 from? Think about it this way. I'll convince you all pretty quickly. The 15% is the down payment. So what is not the down payment? Yeah, how do you figure out the rest of it? 15% is the down payment. What does that mean about the other percent? It's 100% minus 15%. So the other part is 85%, hence the 0.85. That's where it's coming from. But you don't have to think about it that way. I just thought, if you're cool with that, then so be it. If not, no big deal. You could put any one of those in the calculator. Let's go ahead and put in some of these values. 0.9. I'm going to put in the former. You could put all of this actually in the calculator with the minus sign and the multiplication. So notice I am putting that whole computation in, 0.15. And it will do everything in line. See, it just simplified all of that in one step.
I have a question while we're on PV.
All right, what's your question?
For the previous problem, we actually put in the calculator to find PV. Why wouldn't you do it for this problem?
So the reason why was because PV was unknown in that problem, as opposed to this problem where we actually know PV and PMT is unknown. So that's why It's just the context of the problem. We put in the calculator whichever one is unknown.
Oh, okay.
So let's go ahead and figure out. So we figured out PV. PMT, put a placeholder 0. FV is 0, and then those two are 12s. So PMT comes out to be not that anymore, but negative 282.54. And of course, my math lab wants the positive version. The negative is just for the convenience of the calculator. And so the answer you would give my math lab is the 282.54. And from here, we can go ahead and figure out the interest. So the interest, we pick either PV or FV, depending on which one's non-zero. Here, it's PV plus PMT times capital N. So PV, the calculator already tells us PV. It already calculated it for us. So we can just take straight from the calculator. So 20799.5 plus PMT, which is negative 282.54 times N. So 8 times 12 is 96. Is that right? Oh, yes, that's right there, of course. So let's compute that. See what we get. 20799.5 minus 282.54 times 96. Absolute value says we ditch the negative sign. And so the interest, so what you would be paying on top of the price of the sailboat, $6,324.34. It's a good deal of money to pay back. Is that about 25%, roughly? Does anyone have any questions before I move on to example 6? If not, let's move down to example 6, which actually may be related to or something relevant to you all. So who in here is under 24 years of age? Or I guess the other question is, who here is over 24 or older? So it looks like us 3. So for you young people, this could be relevant to you. So Bob, he opens up an IRA account. It's a retirement account. And this retirement account is, well, an account, think about it as an annuity. So it's an account he's putting money into, $800 and compounded annually. And he does that every day until his 36th birthday. And then after his 36th birthday, he just decides to stop putting money into it altogether. And it just grows, but it still gets compounded wherever it says annually, even though he stopped putting money in it. And we're going to figure out how much money is in the account by the time he retires. So this is really a 2-part problem. The first part of this is when he's actually depositing money into the account. That's the first part of this problem, actually depositing money into this account. So we'll start with that. So this is his behavior from his 24th to his 36th birthday is what we're looking at first. Or in other words, the first sentence. So let's go ahead and figure out some of these. $800 deposits tells us PMT. That's what he's depositing. 7.2% interest, that's the interest rate. P over Y and C over Y are both 1. It's compounded annually. Annually. It doesn't make any mention of the word monthly. There's no mention of monthly. So what else is there? So because of that, there's 13 equal deposits. And this IRA, since he's putting money into it, it's starting off with $0. And it ends up with, I don't know, however much money it ends up with. So this is everything from up until Bob turned 36. Make sure that you change P over Y and C over Y to both be 1, because we're annual. And so we can figure out the future value to be $16,322.92. But we're not done. That's the first part of this problem. This problem in the homework is not a part A and a part B. It's just do all of this at once, but it's broken down into 2 parts. That's everything he did up to his 36th birthday. After that, he stopped depositing money. Do you know what that means? There's no more TVM solver. TVM solver only works when you're actively depositing money. You're not depositing money anymore, so instead of the TVM solver, well, it says that it's just compounding annually. And guess what that means? We use the discrete compound formula. So there's no more TVM solver because he stopped depositing. And this formula, since it's been a while, just like this, which tells us exactly what we need to solve for. So the starting value, this compounded annually starts where the TVM left off. So $16,322.92. The interest rate is still 7.2% or 0.072. We're compounding annually, which means M is 1. The amount of time, this goes from his 36th birthday to his 65th birthday. So 65 minus 36, which is 29. And we want to know the future value. Two over 1 raised to the 1 times 29. All we have to do is plug that directly into the calculator, and we are done. One plus 0.072 divided by 1, close parentheses, caret, open, 1 times 29, close parentheses, enter. And so the final amount, Bob's IRA, when he retires, is $122,587.62. And all that just from depositing $800 once a year, not even once a month. So besides for that, I am out of time. Great timing. So make sure you are up to date with the due dates. If you have not signed the roll sheet, it is over there on the corner table. Other than that, have a good day.